Hello. What is going on, people? What is going on? What is going on? What did I do here? Oh, yes. Yes. Okay, great. That was a mailbag that we got that was just, here are some things in the how-to. Now, there's also someone who got the compiler infinite loop doing something very basic, not in the basic programming language, but yet, and this is bad. Because we should an infinite loop. We don't like infinite looping. So we need to look at this. Yeah, it's just chilling. Like, it ain't in a hurry. Okay, can I give this? Oh, he found a workaround. Okay, so it's using the $t in a struct. What if I just do this? Type mismatch between the arguments when comparing two procedures. Why don't we say what the mismatch is? That seems weird. Like what? Let's close this out. Just camera state is only set. What's going on with the camera? What? Oh, because of this. Yes. Let's maneuver the camera a little bit. How's that? Let's do that. We're going to angle it down a little bit slightly more, which then means I can have my monitor up a little higher. Could also there we go. Then I could bring it up to, yeah, I could have my monitor way up. That's very good. I don't know how weird that looks. How does that look? Oh, yeah. Oh, I'm all over the screen now. It's, you know, having the camera up that high is maybe not great. You know, maybe we should do a side view. We used to do side view a lot. It's just that gets weird sometimes too, side view. So, I don't know. We'll leave this for now, but we may experiment in the future. Keyboard view. Well, you want to make sure I'm not engaging cheat codes to program the game. Let's actually bring this down a little bit. It's bothering me. It's like, I feel like I'm being loomed over by the camera, you know? Okay. So first of all, why are we not doing a very good job with this error message? And why are we saying it twice also? Because like, okay, there we don't say it at all. So we're generating this error message twice from this call, which probably means, so like when we detect errors in procedure calls, first we decide the overload doesn't match, and then we go into an error reporting. And so like, maybe this one isn't silent check guarded. Let's see. Oh, it is. But, okay, so first of all, okay, so I used to say more. I used to say the following thing, but then I trimmed it back because we're supposed to give other information, and then maybe we don't. Let's see. Argument 1 did not match. See, those types should actually match. So that's weird. Maybe I'm confused. Sometimes I just get confused. But this is a polymorphic struct. It's got an argument, data type is a type. So if we say pointer to thing, that should be pointer to any version of thing for any parameter. This procedure should be polymorphic. Oh, when we pass it, let me give this a different name, because when we print out names of things, I might get confused by the parameter versus the variable, right? So we just call it func. I don't know. It's funky, right? Okay, so func is a pointer to thing of t. Yeah, so we're not doing this correctly. I bet. Yes. So we're supposed to get the t from here and then iterate again and rebuild this. And my guess is that we don't ever rebuild this correctly. And that's why we're infinite looping. That's a problem. But another problem is what's going on? What is going on? Like, why does this not even match? I'm confused. So let's take a look at that. This seems like an easier problem. Okay. Wow, I'm already starting to go to sleep. We're going to ignore this for now. Okay, so we're going to say, what is the site? BBF. Yes. And this is where we do the check. So we're going to do this. Oops. And then I'm going to grab some water. So we're going to go here. They're not going to match. Question is this a yield or not? No. Okay. That means we could go here again and see why they don't match. Okay, they're both pointers. They're not relative pointers. Oh, I'm getting hungry. Okay. So now we are checking these things, and we could probably do the same thing. Yield, nope. Okay. So right, we knew that. I don't know why I typed that again, but we're just going to go here. We're going to put a breakpoint here just in case we want to come back and check this again. Okay, so we step into here. And now we're comparing two struct types. Then they are not the same. And there is no switchable expression. Now I don't remember what this function is supposed to do. I think this function is supposed to return true, and it probably won't. Let's take a look at what we're passing it. Ah. Okay. So, it's a thing. Okay, wanted has an empty arguments block. Given has a non-empty yeah, okay. We might be getting confused by this because this code, let's see what happens. Wanted source, given source. Given source is not set. So source is not set because people are polymorphed from this. So this will fix this in this specific case. All right. So now we hit some other frickin' problem. Oh my goodness. You think things are finally robust, and then you forget about all kinds of things. Okay. Where are we dying here? We're asserting that, so we're trying to yield. And so somebody, for some reason, decided that we have to yield. We could look at that for a second. And that means that our caller has to be able to handle the yield, and our caller cannot for some reason. I don't know why. So this is a pointer to... Yeah, this is, okay. This is way up where we have the pointers to the things. And so why do we not have yields? We're in type check arguments pointer. We shouldn't really... Yeah, I assume we're yielding off type given. No. No. Pointer 2. Wait, what? What? Oh, right. It's a procedure. All right. So this is a different site. So we're going to put that. And I want to know why it yields. Look at all these breakpoints. Let's get rid of some of these. What's going on here, man? So many breakpoints. All right. 6.8 DDA 3.8. Oh. Wait, what? Why is it saying it's here? Oh, because it's a different... These two pieces of code look very similar. All right. Let's go here at the BC0. See, now we're like debugging maybe a totally different problem. It's a disaster. Okay, we're going to check this. Data breakpoint 6.7 DDA38. Okay. Data breakpoint DCC 5.8. Okay. So we try to do find compatible anonymous member on the two structs. And one of them is a polymorph source. Right, so I assume we're yielding on this one. It's still in the infer pipe, yeah. Okay. So why are we here? With a type that's in the infer pipe? It's because it's a pointer to it. And pointers are special for various reasons. And that specialness does cause us problems sometimes. It's been a while since we had this kind of problem. I'm trying to decide, so there's two ways to approach this. One, handle the frickin' yield, which we probably should do, because there's probably some other reason we need to yield here anyway. But a different approach is, why are we even here if this type is not ready to be processed? We're pretty deep down. So like, should we detect that at a higher level? Problem is, I don't think we can. I mean, we could, but it would be a very special case, one-off ting-tangler. Chat is very quiet today. How is everybody? How is everybody? Dune was good. I know, because they said the slow blade penetrates the shield, so you know it was good. But then they didn't say the spice must flow, so that part wasn't good when they didn't say that. Nobody received look, if you're expecting notifications, I don't know what to tell you. I don't know. Just think about what that would require, notifications. Think about it. Think about all the massive amount of technology that would be required to tell you when the stream begins. Could there be a dedicated string type that always has an up-to-date hash in it? No, that's not the kind of programming language that this is. If you want to make a string type that gets a hash of your choice updated when you perform operations on it, I mean, you could make that. The thing is, it's not like there's a right answer for that everybody will be happy with, right? So the way you do that is you just let people do what they want to do. But I'm also not sure why you want using type. No, just by making a struct, putting the string data in the struct, and then calling functions on it. Like, I also am not totally sure what the benefit of a hash is, because string compares are very fast anyway. Almost always, unless the lengths match, right? Like, the only time that two strings even dereference the data pointer when you compare them is if they're the same length. So, Like a hash is only going to help you when your two strings are the same length. And then you offset that by computing the hash. So well, and testing the hash. Because now also when two strings are equal, you have to test the hash as extra work. Sure is raining today. Sure is very rainy. Okay, so this change that I made might be helpful. In fact, it makes sense to me. However, maybe it doesn't. Ay, ay, ay. See, I have a lot of issues to think about simultaneously here. But one of the issues that's bothering me is when it comes to structs, there's sort of two ways of representing free parameters in structs. And that seems bad. Seems bad. But that's not even what's causing this problem right now. The other thing about this idea of an always up-to-date hash that is computed lazily is it's impossible in a systems programming language. Because you can have some string data and then, you know, some other thread goes off and modifies the string data. And like it's supposed to do that. That's how your program's supposed to work. And then now your hash is wrong, but nobody can possibly know it's wrong, right? So when you propose features like that, you got to think about how they would actually work, you know, relative to an entire big system that does a bunch of things. And it's not easy if you're not used to thinking about it, because there's a lot to think about. Okay. So what are we doing here? So I have this choice, as I was saying. I can, so first I can get more water, and then I can talk about my choice. I could try to fix this error, or like catch this kind of situation earlier, or I could handle the yield. I think I'm concluding that I've just got to handle the yield because even if I put in some handling to catch this error, I don't know how I'm supposed to know that I catch it 100% of the time. So I don't think that's the strat. So it's weird because we yield up here, we have yield handling, but we lose it. We lose it right here in this little nugget right here. In do polymorph solve. And I'm not sure why. This makes me a little bit sad because it might make argument checking slightly slower. But like we kind of got to do this. This is handling a yield here for version 1 of the compiler. Like certain things are up in the air and structural decisions are still, you know, they're still flexible and all this stuff. But some things we sort of just decided this is the way things are and we're going to live with them. And one of them is you have to be able to handle a yield anytime you call check that types match, which sucks. But that's just the decision. That is the executive decision that has been made. Although maybe there's a better way to make that decision. Ugh. Let me think about that again for a second right now. It would be a major change. I can sort of envision a different way to do it. I wouldn't actually want to attempt this tonight, but Okay, the deal is, bring out the sledgehammer. What you had in mind initially is to have a way to make it possible to hash a struct without writing a hashing function for each struct every time. Provided a struct only has int and string fields. So use the struct values as keys in maps. Is this a candidate for polymorphic hashing function? Yes. That is what I would do in that case, is I'd make a hash function that's polymorphic in the argument type. You know, and when it's a struct, you look at the members of the struct and you hash those appropriately. And the slow way to make this is just to have it look at runtime and iterate over the struct members and stuff. But then once that's correct, you could then change it into a version that generates the code at compile time so that there's no runtime cost to inspecting the struct. That is how I would do it. Okay. Like, I'm tempted, you know, when I sat down and I got this bug and I started looking at it, I was like, I don't want to deal with this kind of bug anymore. Right? The problem is I have to deal with this kind of bug because nobody else is going to do it. Even the other people working on the compiler, they can't deal with this kind of problem right now. I mean, they could try, but they just don't know all the little decisions of how it's supposed to work when it's not working and stuff, right? And so part of my goal now is I have to transition this compiler from being a thing that works in my head and that I can fix to being a thing that a broader number of people can understand. Part of that might just be documenting things, nailing down some of these decisions that, like, you know, if you think you might change a decision tomorrow, you don't necessarily document it or like double down on it, right? I forget where I was because I started thinking about something else, like Joe Biden. Um, anyway, so I believe what I was trying to say is at some point there's like, you got to re-architect the thing to be simpler. That's, okay, so a couple of years ago, I was at a very scary point in the compiler where I was just chasing gnarly bugs all the time, and it was not fun. And I was getting tired of it. And I was like, oh man, this is so complicated. But then I figured out ways to simplify it, right? And so now what I'm thinking is maybe it's time to invest, instead of cranking ahead on these couple of bugs, maybe it's time to just do a structural change where we attempt to simplify things. Now, the problem is, I don't know, I'm vaguely thinking of something that might help, but the problem is, like, it's easy to kind of think of a way, like I'm trying to get rid of these yields that are down in here. And it's easy to think of a way to be able to factor the yields up to like the top level function. But that doesn't really help me, because the complexity that I'm trying to get rid of is the complexity that's like outside the check that types match, not inside. Like I want to not have to add a yield here and in all the similar places that require yields. And I don't know, like I can vaguely picture what it might look like to do it. And so maybe the right move is just to think harder. Maybe I just take the day tomorrow and just think about that. Like, what would it really look like to solve this problem so we don't need a frickin' yield? Okay, well, okay, there's two things. One, I could remove the need for this kind of yield in check that types match. But two, I seem to remember there's at least two good reasons to yield right now. So we could find compatible anonymous member, and the struct may not be ready. And the thing is, this could be through a pointer. That's one reason why we yield. This is a weird case that's looking up an enum. Maybe we could get around that, maybe not. This is a, see, we're using the yield mechanism in a different way. Yeah, every time I look at this, I'm like, maybe we just can't get rid of it anyway. Yeah, sometimes it's just complicated and the problems are just kind of big. The problems are just kind of big. So you wanted to hash string fields separately first and then use string hashes when calculating struct hashes. Because if strings change rarely and hashing strings is the most expensive part, the idea was to use string hashes rather than strings when calculating struct hashes. Does it make any sense? Well, a little bit, but again, how do you know when the string hash changed? That's maybe something that you know at the application level, right? Like, okay, if I'm writing this program and I'm also writing my hash function, right? Then I might know that I only change these strings under certain conditions and that the hash remains valid between those times, right? But if you're writing a library for people to use, or if I'm writing the compiler, right? This is why, again, this isn't a thing built into the language. I don't know what you want to do, and I don't know what constraints you want to have, and it's a different situation, right? So some things are very easy from the application level, because you might be like, oh, I know this field never changes. It only gets set at initialization, then it never changes. And then this one here only, changes once in a while. And I can tell if it was changed. So with this kind of thing, all right, here's one more thing that I'll say about this. This is the kind of thing that beginning programmers tend to make a mess out of, or not even just beginning, but intermediate level programmers actually tend to make a big mess out of this kind of thing because they try to do something very general that handles everything. And so it becomes kind of big and messy, and then it still doesn't do what people want anyway. If it's for other people's code, or even if it's for your own code, you end up needing it to behave in ways that it doesn't. Like, the right way to approach this kind of a thing, in my experience, is to just write the most specific thing that you need and then see how that goes, and then use it, see how it goes, and then, if you then can generalize it successfully and profitably, go ahead and do that, right? So what why do you want to hash structs right now? What's that for? Is that a general thing, or is it a very specific problem that you're trying to solve? Just solve the specific problem and then generalize out from there as you are successful, rather than trying to write some big general scheme that hopefully may be successful. I was explaining what the problem was. Well, we're several problems deep now, right? So this probably isn't related to the infinite loop. It's probably, well, it might be, but it's probably a separate bug, actually. So the bug that was reported is probably something to do with polymorphism that we could look into separately, which is also honestly something I would like to restructure a little bit. But when I was, sometimes people give me repros, and then sometimes I try to tweak the repros to see what happens, right? And I tweaked this one, and it broke in a different way. And then I was like, oh, well, we should look at that. And well, that led us down this rabbit hole of like, oh, this thing needs a yield and it doesn't have one. And then that's like, okay, should I put a yield? I do think the answer in the short term is to put a yield. It sucks, but I think that's just what I'm going to do right now. That's a thing that I can do on this stream, is put a yield there and try to make it work. And then, if we want to restructure it later, that's fine too, right? But, one of the policies that I've started to have, I mean, on the one hand, if you think you're going to change it eventually, it's like, why fix this kind of thing and do wasted work if you think it's likely that you're just going to change to a different system that won't need these yields? It's like, okay. Yeah, there's logic to that. And I've followed that reasoning a lot of the time. But also, like, there's something good about keeping it real and fixing all these little problems because you have a valid and correct view of what was required to actually make this approach work. So then later, if I change, like, often things don't work out as well as you thought, and you try to change to another system and you start doing it and it starts looking pickier than you thought, and it has a lot more special cases to handle or something when you wanted it to be really general and clean and whatever. And then you're like, oh, I should go back to the old thing. But actually the old thing had more special cases too that were picky. And if you don't actually chase down a lot of those special cases, maybe you don't know really, maybe you can't make the right judgment call at some point, right? Or, even not even talking about quantity of special cases, but maybe the nature of what tends to be okay. Like in fixing this kind of a bug, I see what tends to be a problem for the type matching. Like what kinds of things tend not to be ready when we want to go and match types. Which means when I'm weighing another approach to the problem, I need to answer the question of how does it fix the problem for those specific cases? Does it, in fact, right? And not confronting those cases means it's going to be harder to think about when I try to do that alternate implementation. And I've had exactly that experience in the past. Anyway, so that's where we're at. So we have a bug snack from the mailbag that I'm starting to think we just may not fix tonight because again, sometimes when I do these late night streams, I'm like tired. I'm still a little bit on Austin time. I'm like, I would say I'm about halfway back to Bay Area time. I'm probably about an hour off of what I usually am. But anyway, why do you want to avoid yielding? Because, okay, well, you can see the answer to this in what I'm about to do because I'm going to add a yield. But the problem is, so if we don't yield, then like this code right here can just say, we've got a local variable I. We iterate over all these declarations and we just do this thing, right? Although we're not actually in the right place. Sorry. Because this one actually does yield, but it was in, it's in this one, which is also like, it's iterating with this local variable I and stuff, right? There's different constraints over how much state you have to track when you yield and stuff, but if we're modifying things like our list of polymorph solves and stuff like we are doing here, then when we yield, we need to come back and start from the same place. And continue from there. And also for purposes of, efficiency, if you yield on argument 17 of a 17 argument function call, you don't want to go back and redo arguments 1 to 16. So like we would have to put a state variable on somewhere that tells us where we are. And then when we yield in the middle of checking these arguments, right, we set that, or, you know, we just use it to iterate, right, so that we continue naturally. God, see, like here, we don't even try. We don't even fucking try here. We probably need to handle this later. Yeah, it's hard, guys. Here we yield, though. After we set, like, yeah, this is like, there's some dragons here. There be some dragons here. Like what we really probably need is a whole struct per argument that has several fields that describes the state of what we're doing. And then that maybe makes the compiler slower, which nobody likes. And then, so whoever is then calling, so right now, because this doesn't yield, oh wait, it does. Okay, maybe that's not so bad. But if we weren't already passing a yield argument here, well, no, I mean, we know that not everyone handles it because like this is null right now, right? No, it is. It isn't. I see. Okay, so it's not that bad. But in some cases, when you need to add a yield, it's like now everybody all the way up the calling stack doesn't currently expect this thing to yield, and they all need to handle it, right? So it's just complicated. And I would like to minimize that wherever possible. You got to try. No, we do not do tries in this house. We do not use try. Try is some bullshit. Do or do not. There is no try. That is true. That is true. Oh, it's a reference to me saying in this piece of code we aren't even trying. Ah, gotcha. Gotcha. Yes. Well, okay. For that meaning of try, then yes, you must try to succeed in the game industry or the compiler industry. Okay. So my conclusion was we just add the yield, and that may not even fix all our problems. Because there might be other problems. But we can at least get past this assertion. Because this is a little bit annoying. It is kind of annoying. Because we need to make like an argument type check state. I really don't want to do it. I really want to be relaxing on the beach with a beautiful girlfriend, getting a massage or whatever, right? Okay, so type check arguments is probably only called from two places. And there may be some state that is not a big pain to set up. And this has a lot of arguments. We kind of want to factor it anyway. Let's just see. I have a laptop, just take it to the beach. Yes, a laptop is much like a beautiful girlfriend, except all the ways in which it is not. Sounded like adding a yield causes a runoff of added complexity. Yes, that is the case. How much added complexity in how many places is a little bit situational. In some cases, it might not be that bad. In some cases, it might be annoying. I would put this one somewhere in the middle. We'll see how annoying it is. We will see. Especially modern laptops. That is true. That is true. Oh, we are landing the easy sages today. It's true. Life is just one sequence of easy sages after another. No, that's not true. Life is pretty good, honestly. It's pretty good. What are we talking about? Look at all the easy sages. Easy Sag crew represent. Okay, so if I'm gonna... So we've got twice as many calls to this as I thought. There are frickin' 4 of them. Okay, where are they? Type check 1 overload. Okay, expected. And we can put the state on the overload info. And in fact, maybe the state just has the argument list sorted and the vargs info. I don't know. Okay. Where's this one? Module parameters call. Okay. This could fucking happen. See, sometimes I don't even try, and this kind of thing is all going to need to be handled. However, since we're not even trying here, we could also just not try for the other thing and clean them both up at the same time later. Here. Where are we? We're inferring a procedure call. Wait, what? Where was this one then? Type check 1 overload. So where's this? Oh, operator overloading. We're searching for the operator that we want to use. Here, this call, this is a generated operator call. So yeah, if we put the state on... It's a little confusing. We could put the state on the call. I don't like the picture forming in my head already. It's doable. It's just adding more complexity we're going to have to pay for later, which I don't love. Okay. And then this one is, where are we at? Infer types for struct instantiation procedure call. Yeah. So basically, we could put a state counter on the call. And for now, it could just be a mess, and it could be an extra procedure or an extra argument to this procedure. And then later we could factor it together with some of this stuff. I don't like this because it adds, like, there's lots of procedure calls in a program. We're going to add some more state to procedure call. Maybe we could find somewhere to put it in the struct that's already a whole so we don't end up making the struct bigger. I don't know. Anyway. Yeah. Procedure call. Oh my goodness, look how big and chunky. Okay, so we have a slot right here where we could put something. Oh, we've just got to figure out what Chunky's deal is. We've just got to figure out what Chunky's deal is. All right, so U32 argument cursor for procedure calls yielding. For argument match yielding. Oh my goodness. All right. So we're going to have to add this argument to here. And there. See, already here, I'm already going nuts. Because we could yield inside either of these. So like this variable that I just added is not even enough. Because we want to say which of these we're in. Because otherwise, what I'm about to do... Okay, you know what? We're going to say... we could at least solve the current problem, because there might be some other reason why this doesn't work or why we end up not liking it. If it does work, then we got to come back here and deal with this in some way, which may not actually be that hard, because like I said, I probably want to group several of these things together, and at that point having an extra Boolean about which of these that we're on is not that big of a deal. But yeah, for now we're going to say okay, I got to pass this argument down to everyone. Probably to be consolidated later. Okay. Okay. So here we'll go while this wait, did I say? Okay, this is a star argument cursor. Does C++ have while do in it? Okay. So we haven't done all the calling sites yet. So this one we don't know yet. Let's do the other ones first. It's kind of a silly name, but there we go. We need to add this in here. Okay, so here we're going to put this thing, but it's going to be on the overload. Dang it. So now we go through all the overloads. Anyway, now on the overload info, we don't have this variable yet, which is a butt pain as well. While x do blah while 0? What? Why would that help? I don't get it. Okay. I broke something. Dang it. This has nothing to do with the bug we were looking at before. It is that procedure calling now doesn't work correctly because of this change that I made. Now, we could verify very quickly. So thankfully, this actual change at the... Wait, why is this not saved? What's going on? The actual change at the site is not a big change. What was the variable called? Something argument matching. Argument match yielding. Oh, wait, this is called cursor. Argument cursor. You know what? I'm actually not even sure the way that that works out precedence-wise. Ah, that was the wrong bing, but a bad. Yeah. Okay, great. We have learned today that that was the wrong precedence. We were incrementing the pointer and then dereferencing rather than incrementing the contents of the pointer. Nice. Okay. Now we're back to where we were, which is that we're still not yielding where we need to yield, but we should hopefully be able to. Now. Okay. So we should be able to assert yield upon here. Okay. Actually, let's do it right here. Before if star yield upon, I hope everybody passes this. They gotta, right? Maybe not everybody does. Ugh. Okay. So check that types match, type wanted, type given. Switchable expression wanted, switchable expression given. Silent check, yield upon, yield upon. yield upon. Okay. Okay. That is good. Now, we just have this polymorph bug, which is the thing that we had started out the night wanting to deal with. And then we hit this. But I believe this. Okay, well, let's make sure all the tests go. Just fix it. Yeah. Just fix it. Just fix it, everybody. Have a good time just fixing it. All right, let's try the Sokoban game. Dude, the last beta shipped on October 20. It is frickin' October 24 already. What even is happening? What is happening? And that one, you know, it was definitely some value being given to the people, but not that much value. Of course, we did October 19 and 16. So, to be fair, it's fine. The amount of value going out to the people is totally fine. Okay. So we still have a game. That's great. I like it when I don't destroy the video game. That's very good. Very good. Okay, problem. Can't just check this in. There's two different no check-ins at least. All right, one of them is not related to this yield, so we could take it out and deal with the yield. The other one was that symmetric procedure call problem. Which I kind of... I kind of want to do something gross there, but I will regret it if I do that. Hold on. Okay. So if we go back to this other no check-in, not that one, this one. If I comment this out right now, that'll make us do worse on our test case here. Because we're back to this. But that's fine. That's actually fine. I mean, it's not fine, but we're separating our problems and we're doing one problem at a time. This has now been designated a different problem. All right. Different problem. Is there any way to deconstruct a struct into variables like field 1, field 2? Does it make any sense? I mean, no, I guess I don't understand. You want to make an assignment where each member on the left of the assignment is assigned to the contents of the struct. I mean, okay. Some programming languages do that. I don't feel like that's a very useful or important operation, because the problem is, as soon as you do that, now you've destroyed one of the degrees of freedom that the struct gives you. Like, a very nice thing about a struct that is underappreciated in programming languages like this is that, like, look, you declare the struct and then you write code that uses it and pass it to functions and stuff. And all that code doesn't have to change when you change the contents of the struct, right? I mean, unless it has to, right? Like, if you add stuff where the code will be broken if it doesn't handle it, then you have to handle it. But otherwise, function doesn't care if you add something to the struct. Now, when you call the function, it just still does it, right? But if you're doing this destructuring operator everywhere, now all that code has to change. Unless you're saying it's a special operator where the names have to match the names in the struct, and that's how it knows which one they are. But even then it's like now you have time bombs. Like, you can't even just rename members of your struct without breaking code that you didn't necessarily expect to break. It just, like, that's the kind of operator that doesn't make that much sense to me. You're still thinking about hashing a struct. The problem you're trying to solve is, if you write a specific non-generic hashing function for that particular struct type, you'd like to guarantee that once you add a new field to the struct and forget to update the function, the compiler would tell you. Aha, yes. I mean, the thing is, there are ways that you can implement that checking at user level. All right. Now, a little bit paradoxically seeming, they may involve hashing the struct, right? But it may be a simpler thing where you just know how many members are in the struct and all that, right? And what they're called. But what you can do is you can have a compile time assertion inside that function that says, assert that some property about the struct is true, right? And what is that property? Well, it could be, maybe, like, the most brain dead simple one is you manually have a constant field in the struct that's like the struct version number, or just a garbage number that's like a hash, and you just change it to something random every time you edit the struct. And then you assert that that was what you thought it was when you wrote the function. That is still a little bit error prone, because you might, well, it's fairly error prone because you might just you might edit the struct without changing that number, right? But if that number is then a hash, then you don't have to worry about updating it. And, okay, so that actually makes the problem one step simpler. It might sound like I'm suggesting a recursive problem where there's never any solution because your hash needs a hash. But this hash doesn't really depend on the data inside any of the fields, right? It's just like, okay, how many members are there? And maybe what are they called, right? And you just hash that, and you make sure that matches whatever it was when you last edited the function, right? Now that said, that's not even necessarily the best way to do it, because that'll tell you like, oh, this function isn't right for the current version of the struct, right? But it won't tell you why it's not right. It won't tell you like what members are missing or whatever. So depending on what code is in that struct, you could actually do a thing where you do a little metaprogram scan of the code for that struct and make sure it is handling all the members. And then you could actually report which member is not being handled. That might be simple. It might be complicated depending on what your code looks like for handling each member. If it's something very simple and easy to search for, then it's easy to do that. And then you don't need a hash actually, right? You just compare all the members of the struct versus everything in that function. Or, right, maybe what you do for each data type or each member looks different and is hard to scan for, but maybe you could put manual markup in the function that says I'm handling this member now, right? So you could have a macro called I'm handling this, where you just put I'm handling this and then the name, right? And that macro like expands to nothing or whatever, but your checker checks for that. And then you can tell people exactly what is not being handled and what needs to be handled, which is a nicer error message. It just, exactly the right way to do this depends on, I think, exactly what you're doing. But I would not do it with a language specific operator. Like that just kicks the can down the road by one step. And it also makes things not work. Like what, in our games all the time, in our entities, we actually have sort of two classes of fields in the entity. We have fields that are like, these are serialized to disk. They're editable in the editor probably. They're undoable in the per frame undo and all these things. And we have another class, which is like, these are intra-frame data used by the engine that we don't want any of that stuff to happen with, right? Well, a programming language feature isn't going to know the difference between those two things. And it isn't going to. So if you say complete on that, now I can't edit the fields that I don't care about and add them without it being a hassle. And then I have to have dummy code that pretends to handle them when it doesn't want to. Like, it's just a whole thing, right? So it's very often better if you can just define your own way of handling these things. I think that is the case. I think that is the case. The last approach I described is if you would complete only on fields that had a particular tag. I mean, you could do it any way that you want. You could do it with tagging. That's how, so that would be a natural way to do it for the game, right? Because we're already tagging things that way, right? So we know what those tags mean and we can just use them. But what I'm trying to get at is, there's other things you can do depending on, like, I don't know, I don't know how your program would work and what kind of things you want to do. Maybe for some reason, like, you just want to have a naming convention where the fields that are in one class all start with an underscore and the other ones don't, right? That might just be a thing that you like or you want to do. And then rather than putting in work to like search for notes on the members, you could just say, hey, does the name start with an underscore, right? So like it depends. It depends on what you want to do. It's still raining out. What's the weather going to be like tomorrow? Raining, but less, it says. Less than today. Wow. Okay. Yeah, I mean, there's a lot of different ways that you could accomplish this. Like this is where, okay. This is where it gets hard to recommend something specific, because like the best way to do it sort of depends on like what else are you going to want to do and how can you hook into that and cooperate with that, right? Yeah, it just depends. Just depends. All right, I'm going to want to go to bed eventually. So I put that no check-in into the to-do file. So now there's just one no check-in, I think. Oh, dang it, there's two. What is this one? Oh, this was this problem. That is also going to be a separate thing. That like we're not, this might only be happening because this bug is happening anyway. This was just an investigatory step that I did to like get more information about what was happening, which we have done. Now, the one no check-in that's here is this one, and I'm not super happy about it. Okay. Here's what I'm gonna leave it. Let me think about this. Okay. I'm gonna write a note here. In principle, this setting of argument cursor to 0 is incorrect because, along with the general yield handling here, because if we yield in the middle of this second call, we will then go back and type check the first call again later, and may end up doing a bunch of wasted work. However, it should not be possible to yield only in this second call for correct programs. Let's not say for correct programs yet. Because we already type checked these arguments, these same arguments in the first call and finished. since the argument types are the same, just in the opposite order, there really should be no yield here. Famous last words. Oh my God, it's October 2021. Dogs and cats living together. Yeah. Let's make this argument cursor signed, which I should have done. That might be it for tonight's little stream. We added a yield. It wasn't that bad. I say that now, but like I might have introduced some bugs. Like, I don't think I did. No obvious bugs, but like, ugh. So like, I do want to think about this longer term project of how do we get yields, get rid of yields here. And that might be a thing that I just think about tomorrow and see what I can come up with. All right. I'm going to commit this. Uh-oh. Oh, I pasted it into the to-do. And the no check-in string prevented us from, yeah. Okay, so I got to look at this tomorrow morning or something. Put that back, put the other thing. There's like a polymorph problem. There's like still two more problems here. I don't think either of the two problems is super nasty. It's just that each one of them brings up questions, fundamental questions about things that I'm doing that could be simpler. So yeah, figuring out how to make them simpler would be a good thing. All right, I'm going to go to bed. Thanks for coming by to our short, it wasn't that short, it was almost 2 hours. It was medium short stream tonight. Thank you for coming by. Yeah. I hope everybody's having a good night. Oh, I missed some questions. Have I ever felt unmotivated to do my job? I mean, you still do it, but maybe it's a bit harder to push yourself to do so. Yes. Definitely, I feel that way sometimes. I think everybody does. Do we have any guarantees about the contents of padding bytes? I'm pretty sure that I guarantee they are 0 if, okay, like if it is created by the actual initializer for the struct, right? But you could obviously just allocate some memory and put things in there and not do that, right? So, yeah, it's something like that. That said, we've been talking about getting rid of padding anyway. Yeah, padding might just not be a thing. We'll see. All right. Thanks, everyone. See you later.